So today we're going to be solving a question from Nelson Physics 12. So the question reads, the record distance for the hammer throw is about 87 meters. To achieve this distance, an athlete must produce a centripetal acceleration of nearly 711 meters per second squared. So our first part says, given a radius of 1.21 meters, calculate the speed of the ball when it is released. So let's start with our givens. The radius is 1.21 meters, and the centripetal acceleration is 711 meters per second squared, and we're solving for the speed, which is v. So this question is pretty straightforward, as we have a formula for centripetal acceleration is v squared over r. So we just rearrange this formula. So speed, v, is equal to centripetal acceleration times the radius, and then we square root the whole thing. And then from here, it's just substituting everything. 29.3 meters per second. And there's your final statement. Moving on to the next question. The athlete lets go when the ball is 2.0 meters above the ground and moving at an angle of 82 degrees above the horizontal. Determine the range, ignore air friction. So first, I'm going to start out by drawing a diagram. This is the ground. This is where the ball is released. The path of the ball. And so I've just fast forwarded the video a little bit. I've drawn a diagram, that's all. So let's jump into our new givens. Given our velocity v1 is equal to 29.3 meters per second as solved in the first question, and it's 42 degrees above the horizontal. And then our vertical displacement, delta dy, is is 2.0 meters down. And what we're looking for is our range, delta dx. To solve for that, first we're going to need to solve for the time that it's in the air. And we're going to find delta t with our vertical component. And the formula we're going to use is delta d is equal to v1 delta t plus 1/2 a delta t squared. Positive is up. So from here we just plug in our values. Negative 2.0. v1 is equal to 29.3 sine 42 delta t plus 1/2 a is just the acceleration due to gravity, negative 9.81 delta t squared. From there, you just rearrange this equation so that it gives you a quadratic equation. So it would be from here, you can solve for delta t using the quadratic formula, which is just equal to So if you plug all of that into the quadratic formula, I just plugged it into my calculator, you'll find that delta t is equal to negative 0.0995 seconds, 4.097 seconds. Now, we can reject delta t equals negative 0.0995 seconds because time cannot be negative. Okay, so now we can finally solve for the range, delta Tx, now that we have the time. So we'll do this using just the horizontal components. And we're going to use the same formula, delta T equals V1 delta T plus 1/2 A delta T squared. This time, A is equal to 0. Since there are no forces acting on it, we can disregard the second portion of this expression. So it would be V1, using the same idea as before, we're going to use cosine this time, is going to be 29.3 cos 42 delta T. Whoops. 42 times the time, which is 4.097, as we solved before. And then your final answer will be 89.2 meters. And then that's your final statement.